Alright, let's do an email. Hello, I've watched your channel and I've been a subscriber for a long time now. Well, thank you very much. I do appreciate that. I was wondering if you could do a video on a Frisbee. Well, sure, I could do a video on a Frisbee. Let's see, we get the patents up. I mean, there's really not much to them. They're kind of just a disc. I mean, yeah, there's really not much to these things. We can go over the theory of flight, if that helps. Well, let's see. Frisbee's flight is governed by aerodynamic lift and gyroscopic stability. A Frisbee moves through the air. It creates lift and drag forces. I don't know. You know what? Why don't we just talk about the ride Frisbee instead?
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? On today's video, kind of in the topic of the flat ride area, I get a lot of flat ride requests from you guys out there. So I wanted to talk about a Frisbee. Now, Frisbee, the term is really generic. So I have to narrow this down. I have experience with several style Frisbees, but the one I have a lot of experience with in depth is a HUSS Frisbee. And more importantly, it was one of the ones made in the late 80s, it says mid 80s to early 2000s. So this is one of the, I would say one of the original models. So I wanted to go over kind of some general points of that. I'll talk about their construction and set up a little bit, and we'll go into operation, and then I'll pull out what I can remember for stories and troubleshooting at the end of it. So if this is your first time here, make sure you like and subscribe, do all that stuff downstairs. It does help me out. And let's get into this. All right, so the Frisbee is not a unique model. It is a generic term. Where it came from first, honestly, don't know. The ones I have experience with are made by HUSS over there in the Germany area where HUSS was from, and now the manufacturer HUSS has changed hands several times. So there's always HUSS GmbH, HUSS, butcher this, but Masha Fabric and GmbH as well, I think. I'll get a lot of corrections on this down in the comments, I always do. But I figured I would go into this. All right, so the ones I'm talking about, these are a 40-passenger model where you sit basically facing the inside of the gondola. These were built in the mid-80s to the very early 2000s before HUSS stopped making them. They were both available in a traveling model and a park model. The one I'm familiar with is a park model, but realistically they're the same things. Just on a traveling model, they simply just had a subframe that connected the drive system, which was also on the trailer, to everything else. So there wasn't too much difference between the traveling one and the permanent one. So we'll start with the structure itself. The structure itself was a 20-meter structure, and this came out to roughly 65 feet, right? That's 20 meters tall. And it came with 4 legs that would come down in 2 arches. And each one of the legs where they mounted down at the base had a giant swivel bearing down there, giant pivot bearing. This was essentially a ball bearing mounted inside of there. The pin was roughly, the pin was pretty good size. I'm going to say the pin was roughly 120 millimeters in diameter, and it sat inside of a ball bearing that was, I don't know, 300 millimeters across. That thing was huge. And it sat inside of there. And the fun part to watch that is if you stand next to the footers with the ride running, as the gondola would swing out from one side to the other, those footers, those legs would actually pick up a little bit. You could actually see them pick up and push back down in there. So there was a lot of stress on that structure. The things weren't exactly lightweight. HUSS is known for making things that are heavy duty and built really stout. And this was no exception to that rule. I should probably get into this before I get too far in there. One of the things that sets these HUSS models apart, these early HUSS models apart from later revisions. Again, HUSS continues. They still do make Frisbee models. They're just not the one I'm talking about. And if you look at like Wikipedia and things like that, there is a Frisbee variant model out there. There's tons of them. Almost every manufacturer makes some sort of a Frisbee model, whether they call it Frisbee, and a lot do, or they call it something else. Like the latest one I had experience with was a Giant Discovery, but essentially when you Google it, it comes up also under a Frisbee because they're kind of similar. It spins and it swings, so it kind of gets dumped into the Frisbee category. So that is the main difference, is that the one I'm talking about has its drive motors underneath the gondola down on the ground, and pretty much all the other models after this particular setup, they all switch to the drive motors being up on top. So for this one, if you look up on top of those legs that I was just talking about, right where they all go to the very top in the center, up there, there's nothing but a big hub where those arms join to, and then there's two very large slewing rings, one on each side. And those slewing rings connect to the center arm. Now those slewing rings wear down. They do have wear to them. So every year we had to go up there and check the measurements on the slewing rings, and they gave us a way to do that. But it was really simple. It was simply just as the slewing rings would wear, the inner and outer pieces, let's see if I could do this right, like this, they would essentially start like this, and they over time they would drop down because the ball bearing on the inside is wearing out. So they would give us points of reference on the inside and measure it. They couldn't have more than like, I don't remember what the exact dimension was. I'm thinking it was like 1.3 millimeters worth of wear, worth of movement, but it might have been 1, 2, 3, like 1-3 millimeters. But I remember the differential wasn't hard to check because you basically went to the very bottom and measured the gap on the slewing ring, and then you went to the very top and measured the gap on the slewing ring up there. The gap on the top will be bigger than the bottoms, and then you'll have a differential. That is it. You could also measure the left and the right, which would be the differential as the arms swung out way to one side. But the slewing rings did have some wear. We had to check those annually. But there was nothing to them. They were not geared. They were simply just giant bearings for that arm to hang on to. Now, we go all the way down that arm, and that arm had some service bulletins to it. I remember towards the end of the ride there, they produced a service bulletin that found cracking in the arm. So that was a really dangerous one. If you've ever seen out there, there was a similar pendulum style ride that was over in India where the arm just split in half while it was running and dropped the entire gondola. Really bad accident. But that is one of the really bad things with driven models. By driven, I mean that's the other style Frisbee that I'm not talking about, where it has motors up on top. Because if you push the motors too hard one direction, the stress of the gondola goes into the arm because it's a big weight out there and it's pulling down on that. So all the stress goes into the arm right there. These Frisbees are very light stress because they simply work with gravity. There's no power motion against them, so they're the best. At the base of that arm, there is another slewing ring, although this time it is a geared slewing ring. It's an external geared slewing ring. The internal mounts to that arm. There's a flange down there that it mounts to. And then the external part that has the gear on it is mounting to the bottom of the gondola. So the gondola sits on top of that slewing ring. It's what it rotates around, and it is what also drives the gondola for rotation-wise that we'll talk about a little bit later on. But that is an external geared slewing ring. It sits there. Underneath that slewing ring, there is the gondola drive motor. This is a large DC motor that sits on the side of the keel. If you look underneath the keel as it swings, underneath the gondola as it swings, you can spot the drive motor off to the side. It kind of just hangs off to one side typically. That motor produces all the rotation for the ride. The next thing down is the keel itself. The keel is just a large banana-shaped piece of metal underneath the ride. It's hollow on the inside. There's nothing inside there, but there is support ribs that reinforce it along the way. There's basically, it's a giant cavity, and they welded plates across the inside to support it as it went across the drive tires. And then there's the face of that keel, which actually makes the contact with the drive tires. The face of that keel actually has this stuff on the outside that looks like stucco. It's a very abrasive, very hard coating on the outside that was meant to produce traction to the drive tires. Every one of these rides that I have seen so far, that coating right where the drive tires run has been worn off. There's nothing there, and it's just down to bare steel. Ours was no exception. It had that coating towards the outside, and right in the center there where the drive tires ran, it was just blank steel sitting there. It never rusted because, man, it had a lot of rubber caked onto that thing. But that is the keel. That's what makes up the last bit of the suspension arm and gondola swing. So that's it for there. Moving down away from that, now we're out of the structure in the ride. Underneath that is a big drive motor that sits directly underneath that arm. That drive motor was drive motor number 1. And that drive motor, they're considered servo drive motors. They are DC, they're very powerful. They go through a 90-degree gearbox, and then they have a large inflated tire on the outside. The tire is very similar to what you'd find on a big rig tractor trailer driving down the road. The tire was inflated to 150 psi. The servo motors produce just an ungodly amount of torque on the things. They're crazy. And the number 1 servo sitting directly underneath there had a pneumatic brake attached to the outside. That pneumatic brake was not actually to slow the ride down. That was just for the homing process. Once the ride came to a stop at the end and the swing stopped, you would hear this little tiny bit of air, this little psst. Right when it did that, that was the actual brake grabbing onto that so that drive motor couldn't go anywhere while people loaded and unloaded out of the gondola on top. Just outside of the gondola, towards one side, there is another servo drive motor package, the exact same thing sitting there. That motor had no brake on it at all. It was simply just the motor, the gearbox, the drive tire. For both of these, they had big pneumatic bladders underneath the gearbox, basically, and the bladders pushed up on the drive tires. Now, that produced the tension for the tire to actually rotate against the keel. So that was very necessary for those. And then if you look at those things carefully, you'll see to the outside a set of shocks. 2 shocks, or actually 4 shocks going down from the bladder side and 4 shocks going down from the counterbalance side, which is actually where the motor, because the whole thing kind of teeter-tottered in the center, coming back that way. And those shocks were there, that drive tire was sitting up higher, so once the gondola comes down and hits that drive tire, the initial reaction is that tire wants to fling down. And then as it does that, it wants to then bounce back up and continue to bounce up against there. But they didn't want that. They wanted a nice solid motion, solid movement. So what they did is they put those big shocks on there with different rebounds to them on all 4. But they were all 8, I should say. They were the same size, so they were interchangeable. You could put them anywhere you wanted to. But basically what that did is that as it came down, it was very tough to push the drive wheel down because of those shocks, not just the air, but because of the shocks. And then it was also tough to just let it spring back up. So it kind of made the whole assembly move extremely slow when it acted. That put a lot of extra pressure on that drive tire, but it prevented skipping. I've worked on one of these things when those shocks were blown out, and they chirp and skip and do all sorts of stupid sounding things once they get to that point. So good shocks is very necessary for those 2 drives. Okay, let's go back up to the gondola, because I just said gondola and kind of skipped over that. For those of you who are saying, yes, I'm pronouncing gondola wrong, Let's talk about the gondola. The gondola had 40 passengers that faced inward towards the center. There was only 2 spots to load and unload, and typically what they were 180 degrees apart from each other. So when the ride homed at the end, it had to home the gondola in a place to where the pathways would line up 180 degrees out with each other. And then they would use pneumatic actuators to release the restraints. They say, well, where does that air come from? On the inside of the gondola, and there in the center hub, there's typically this big cone around the inside where you can't get to that stuff. But on the inside there was a air compressor sitting there. That doesn't work good on swinging stuff, but they used a oilless air compressor, so there was no fluid moving around the inside. So that thing could turn on and run whenever was needed. But the air pressure was only needed for unlocking the restraints. Locking was all done spring-loaded and mechanical, so you only needed air to open the restraints. So, been out there plenty of times when we blew an airline off of it, and then you have to go manually unlock those restraints. Not a very fun process to do. In the restraint itself, there is 2 safeties. There's 2 locking mechanisms in the restraint. They use dual shafts that sit down right behind you. The first one is like you're familiar with on a roller coaster. It is a ratchet and paw as it goes down. So as you pull that restraint down, you can hear those go click, 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 click as the 2 ratchets jump in and out as it goes down the toothed, I should say the 2 paws go in and out as they go down the tooth ratchet on there. So that was linear, so they go as it locks. Now, on the other shaft, on the one on the other side, there was a safety paw in there. And what the safety was, it was a giant block in 2 steps. And then what would happen is you pull it down, there was no teeth on that side. It was simply just a relief. That's all it was. So the 2 paws would be sitting here like this. And as that thing came down, paw number 1 would go click into place. And then as the second one came down, it would also go click into place like that. Once that second paw dropped into place, a limit switch on the side, an electric limit switch, was made. And then that limit switch told the controller, which was just relays in the center, told the controller that that seat was closed. And it produced a LED signal, which is typically on the top of the seat. A little light would turn on saying that the seat was closed. Now, every week, you had to take a special tool that inputted in there. That tool was an exact dimension. The exact dimension I don't remember honestly, but I want to say it was something like, it was like 264 millimeters or something like that. It wasn't huge.
That's what she said.
It was about this big. But it was this dimension. And what you had to do is you had to go into each restraint and put that underneath between the seat back and the restraint and close that guy down until it made that dimension. It made that little stopper inside there. And then what you would have is that just before that, that light should not be on. And then pretty much as soon as the restraint touched that device, that green light or that light on top would turn on. Those LEDs were just for communication. In fact, they were on the, if you would go right where the entry and exit are inside there was some LED indicators that lined up alongside. And basically you had, I believe it was 5 seats tied together for one LED indicator. So once you made 5 in a row, 1, 2, 3, 4, 5, you would have that LED indicator on the side turn on. So that was one thing that the operations had to check when they started a cycle. They had to get up there and they had to go make sure all the green LED indicators were on. There was 1, 2, 3, 4, since there was 2 pathways in, 1 on each side. They'd have to make sure those are on before starting the cycle. If they weren't on, the cycle should not start, because that was the ride's way of saying, hey, there is something open. Now, the way it communicated that was through the slip rings in the center, basically right above that geared slewing ring down there at the bottom inside the gondola. there was a stack of slip rings up there that transmitted the information from the inside to the outside. Wasn't too many of them, wasn't doing a ton of information. Basically, it had two sections. One was basically the bows 1 through 20 were open or closed, and then the other one was bows 21 through 40 were open or closed. Now, they were simply just single wire communications, so all the individual open and close information was held on the gondola. It was relays and things like that pulling in. And then they just commuted the one wire to go out to say, I'm good and I'm good. And then the same thing when you had opened the restraints and all the actuators opened, they actually daisy chain checked them the other way around to say that they actually did open. So you can actually have a bows fault when the things opened up if all the limit switches didn't make any open position either. That was a fun one to chase down because one would fall out of adjustment and it didn't have a good way to tell you which one it was. It would lower it down to 5, but that was it. That dimension I was talking about though, where you put the indicator, where you put the thing, I say thing because there's really no good, it's a checker, it's a fixed dimension piece, that's all it is. Ours was very simple. It was a block of wood that we had cut to the 264 millimeter or whatever it was width. That's all it was, and we kept it in there and we had labeled it and just said, okay, that's all it is. And we put it in between the restraint and the seat, closed it down, off, 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 and then as soon as it made that piece of wood, turned on. It was like, good, okay, that restraint's good. And we moved to the next one. But this is one of the things, I've always poked at this. I thought it was funny. HUSS it's a German manufacturer. Things, especially technical, doesn't translate really to English well. So some things are translated and they kind of fudge the verbiage a little bit to make it to where people that only speak English can understand what it is. So they give that dimension, that largest dimension right there, they point to it and say, for fattest guest. I always thought that was funny. For fattest guest. It's like, they are not wrong at all. I mean, that is the biggest person that can fit in there. So if you close that restraint and you don't get that light, that means that you're too big. You can't ride. Sorry, you have to leave. So now I want to talk about a cycle, an average cycle on one of these rides. So where I was, we only qualified one cycle. Fair rides, this is a traveling ride that would show up at a fair. Fair rides typically have multiple cycles you can select. Plenty of cycles through them. But in a lot of parks, let the operations just choose whatever cycle they want to run. In our case, our inspectors did not like that we would willy-nilly let operations choose it. So at the very beginning, they said, you guys, we have to qualify each cycle that you want to run, and operations can only use those cycles. I guess it was a big deal because we only qualified one cycle. That was it, nothing else. So I can't really speak for the other cycles that are out there, but they're all just variations of the same thing. There's really not much difference in them. Some of them swing really high, some of them don't hardly swing at all. Some of them rotate really fast one way, some of them don't change direction. It's minor things like that. But let's talk about the cycle real quick. So the one that I was used to running, you would start the cycle, and what first thing it would do is release the motor brake. That way the drives were enabled, release the motor brake. All right, while the motor was running, it would start and go one direction. Now, it would always start out going the same direction because the ride didn't know how to accelerate. What they did for acceleration is they said, okay, here's your parameter, which was a tachometer feedback from the drive. Here's this parameter, add 15% to it. As the gondola would swing up higher and higher, they would start at a very low percentage. They said add 5% to it. When the gondola would swing out to here, they would say, add 10%. Then here it's like add 25%. Here it was like add 30%. And then it started going back down the higher up it got on the other side. So they wanted the gondola to come way up to the almost 90-degree mark, but not quite 90 degrees. when you use that signal amplification modification, all you're doing is taking those numbers, those pulses, turning it into a frequency, and then adding a percentage to it. That's it. So at the very start of the ride, you hit the start button. What speed are the drives going? They're going 0%. So what's 0 plus 10%? Well, 10% of 0 is still 0. So it won't go anywhere. So that doesn't work to start the cycle. So each time they start the cycle, they have to tell the motors manually. They turn the motor on and they say, okay, go X amount of RPM with X amount of torque that direction. And then once it does that, it starts moving it back that way. Then the encoder at the very top watches the angle of the arm. And this is one of those, I've gotten these wrong before, but I think this one's correct. This is one of those where the arm had an absolute encoder on it and it would watch the angles as it would swing. So it said every time, turn the motors on, get it to go this way, and wait till the arm gets to 6 degrees. And then at that point, reverse. And then once the ride went into reverse, then it simply let go of that pre-designated on this direction, go that way. It just went into reverse and then waited for the gondola to move. So as soon as it went into reverse and the wheels were pretty much back at neutral, the gondola would start moving on its own. Gravity, right? That thing still works. It would start moving on its own, and then as it started moving on its own, the absolute encoder would start producing a feedback signal, and then the speed on the tachometer of the drives would start receiving that signal, and then they would start doing the math and adding that 5%. And it was like, okay, it switched. The gondola starts to swing again. The drive says, whoop, it's speeding up. Let's see, what's it at? It's at, not a good way to do this. Let's say it's at 30 inches per second. Right? We'll just make something up for this. It's moving at 30 inches per second, so the drive instantly takes that signal, runs the math through it, and says, okay, speed the drives up to 33 inches per second. And then as the drives accelerate, the drives start accelerating, the arm speeds up to 40 inches per second, and the drive says, okay, do 44. You see that it's always kind of in phase with itself as it goes. So as we move one way, all we do is just push the signal just ahead of it, and then we stop, and once it starts swinging the other way, we just push the signal the other way ahead of it. And then as it gets higher and higher, it becomes more forgiving, and you can just keep adding more current and more amperage into those DC servos, and you could keep pushing the drives further ahead of where the gondola, and you get that faster acceleration until you get up towards the top, and then you slow that phasing back down. So it's like, okay, can't go too high. So they had a height limit, which I'm saying it's not a physical height limit, it's a degree limit. And it was right around 85, 86 degrees, somewhere in there. In the morning. All right, so now we've got our gondola moving. And then once it starts to move, once it gets a little bit off and the program is now taken into effect, it's like, okay, program's running now. We're starting to amplify the signal from the arm and get it to actually swing left and right now. Once it gets into that phase of the program, which is just a couple seconds in, the drive motor for the gondola turns on, it enables, and it starts to move one way. Typically, this doesn't do much. The one we were on, it turned on and it spun one direction for like a minute, and then it slowed down to a stop and then spun the other direction. It didn't have a number of rotations or anything else like that. The ride didn't know where it was spinning the gondola. It just knew every once in a while the flag plate for the gondola would come by and trip its sensor, and it would say, okay, great, I know it's there. That's it. Just a one little flag plate as it passes the proximity sensor. And that was simply just to tell the ride at the end that the gondola was in its home position, safe to load and unload. So it would do spin, swap, go the other way. It would be swinging at the same time. And then after a predetermined height, cycle series, whatever you want to call it, which was different for everything. So I can't say this is the way they all functioned, right? The programming changed from ride to ride, model to model, like everything. It's all different. So I can just say the way mine was. So after a predetermined amount of time, once it was going, it typically got up to about the same height every time. It would just do everything, the acceleration, it would just start deaccelerating the same way. And then it would bring the gondola back down, and then right towards the bottom, it would slow the gondola down and start its homing process. Now, 9 times out of 10, the gondola would home and stop spinning, while the pendulum was still swinging, while the arm was still swinging. So they would stop and do that, and then once it finds home, what it would do was stop it down at the bottom, and then once it registered that the DC motors were off, the brake was applied, the gondola was in the home position, which means its pathways were lined up on both ends, then it would give the operator the ability to release the restraints. So that was a general cycle. At this point in the video, if you haven't already, please make sure you like and subscribe and give me some comments down there. Let me know if you got any fun stories to add on to these. And then let me know if you want to see something for topics in the future too. I'm always up for new stuff. I've got a list of things that I'm making, but sometimes somebody says something and I'm like, oh yeah, let's do that one real quick. That really sounds like fun. I do enjoy getting that information. You guys come up with a lot of good ideas for videos, so let me know if you got them. You can also email me at ryantheridemechanic@yahoo.com. Let's get back into the video. Now, we had manual mode for that ride that we could do stuff as well. It depends on what type of an inspector you were working with the ride, but you can do a lot of things in manual mode. One of the things I liked doing was I would turn it on, turn the spin on, and just barely creep it up just to where the gondola barely starts to move. It just starts to rotate. And then I would walk away from the panel and get my flashlight and stuff out, because our backs, which were all the mechanical components were, everything was clear. So I would just sit there with flashlights and shine through and look at everything as it went by. And then I would do all 40 restraints that way. I could look at the top where the clevis is attached to the actual restraint itself, and I can watch those from the outside. Spend a while doing that outside process, because that took a long time. The other way, which takes even longer and is more complicated to do, which is to do it with no power on at all, which means you need 2 to 3 people up there to push the gondola to get it to rotate, so you can actually rotate the gondola and see the outside. So typically it's 1 person inspects while 2 people push, and you kind of end up doing the same exact thing. You move along to the inside, then you can look at the restraints, look for cracks along the restraints. Each restraint has 2 roll pins on both sides. It has to be firmly inside and present, so those 2 pins needed to be checked every day. And then we can get out to the manual mode operation. Manual mode operation, there wasn't too much to do. There was 2 sets of, well, actually 3 sets of safeties you had to check. The first one, kind of the more complicated, kind of the trickier one to do, which was drive swing number 1 overspeed. There were special keys you could put in the cabinet, turn them, and it basically removes the safety to prevent the drive from going too fast. Because the drive was pneumatically applied against the bottom of the keel the entire time, what you actually had to do is go out there, drain that bladder down to let the drive come back down away from there, and then you had to stick a piece of 4x4 or something like that in between the gondola and that drive, and let it come back up. That way it pinched the wood inside there and wouldn't go anywhere. That way the motor, the tire, was not touching the keel at that point. So then you would have to go back and start it in the manual process and take that swing drive number 1 and rotate the speed up there until basically it got up, RPM went up, 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 and then it would eventually just trip and shut off. And then you get an overspeed error. Okay? So you had to repeat the process just without the wood, since swing drive number 2 was not underneath the gondola, it was off to the outside. You would have to repeat that process for swing drive number 2, make sure it tripped, went over speed. The next one is the over height. This is the tricky one to do. You have to get the drives warmed up, just make sure everything is warm, the tires are warm, all that stuff. And then you have to go out there and turn the ride on and turn the manual swing all the way up, and you just get that ride to start swinging up as high as it would go. There's no like, yes, that made 89 degrees or whatever it is, but there's two flag plates 180 degrees apart from each other at the very top on the slewing ring. Now, flag plates, if you're not familiar with them, all they are is a piece of metal that's bolted onto the side of the slewing ring. That's it. Just a piece of metal about the size of a credit card, nothing fancy. At the very top of the ride, there is a proximity sensor up there that is just sitting out in the open. And what it's looking for one of those two flags to get in front of it. If one of those two flags goes in front of that proximity sensor, that tells the ride that that arm is full out at 90 degrees and that's too high. So what you do is you take the manual mode, turn it on, spin the thing up, and let it just swing out there. It takes about 3 or 4 minutes to do, and finally it gets up high enough. And what you listen for is the drives to start feeding back. Funny enough, it doesn't really produce an air, or at least ours didn't produce an air. So it would go up there, and each time you'd hear the drives speed up. They wind up, kind of make a whining sound, be like that. So each time you'd hear those drives speed up, and then they'd slow down, reverse, and they'd keep doing that time and time again until eventually the arm got way up there, and you hear them, they'd speed up that last time and go, and they'd change. So they'd go ramp up to what they're doing, and then suddenly they flatline. And just, that's the ride's way of saying, whoop, too high. We got to slow that gondola back down. And then it would come back down. So that is the manual overswing test. One of the ways we always knew when that ride had a critical fault is when it has a critical fault, and that's something that it can't easily recover from. This would happen from time to time, a bows, which is one of the restraints, would register open. That was where one of the limit switches was just barely made on the person's restraint, and that jostled around while they were going, and that limit switch finally came undone. Not the restraint came open, just the limit switch came undone. As soon as that happened, it went, whoops, I've got an open restraint. So it kills all power to the ride and just shuts the entire thing down. And when it does that, it would be typically in full swing, and the drives just shut off. The brake on swing number 1 does not apply. It turns off, but it does not apply. It's actually got it's got safeties in its circuit holding that brake open. It needs power to apply. That's an interesting one right there. It needs power to apply. So it does not turn on in the event of a power failure or anything else. And the reason for that is they don't want too much torque going into that arm, the big swing arm. They don't want torque going into that thing to slow it back down. So what would happen is that our shop was close to this ride, just down the hill from it. And you could be sitting there working in the shop, and what that would sound like is that both those tires would stop. Now, have you ever heard a car lock up its tires out on the highway? It's like that. It sounds like that. Not as long because the gondola is very short. It's only 30 feet in length, 20 feet in length, something like that. But as the arm has come down, you would hear it across both drive tires. It go as it would swing out, come back, go. So we would be down in the shop working on stuff, and you could be doing whatever in the middle of doing something, and then you hear that, and everyone would just kind of start looking around like, who wants to, and then someone's like, I'll get it. They grab their bag and they start heading out the shop. It's like, okay. Because it was so audible, we knew that ride was down 2 minutes before our operations dispatch ever called it out over the radio. But we were good at getting up there and recovering it. The biggest pain in the butt there is that if you couldn't turn the ride back on, i.e. the registered restraint was open and it was still registered as open, you would have to manually push the gondola back around. And when you got 30 plus people sitting on the thing, that is really heavy to do. Most of the time, one person can't do it. You need 2 people, or if the operations is cool with it, you can get them to help you. But honestly, when maintenance is there, they're not supposed to leave their little spots. So do what you can with that one. We had a funny story one time with that ride because, like I said, those restraints are monitored for the fattest guest. And we went up there for a ride would not start call. And it was like, what's going on? They're like, ride won't start. So we checked all the restraints. Yeah, everything looks good. Closed them down. Start the ride. Starts up just fine. Okay, double check. Stop it. Open and close the restraints again. Yep, we do this a couple times, like 3 times. All right, call it up. Called it up, and we left. Like as soon as we got back to the shop, the ride was called down again, won't start. What the heck? So we went up there again, and we're like, what's going on? They're like, same thing, it won't start. So we did it again, like 3 or 4 times again. We cycled the restraints. Each time the ride started. We're like, okay, I don't know what's going on. And then this next time we said, all right, try this. The next time it goes down, don't unload the gondola. Don't unload it. Just call us up here. We'll be close. They said, okay. So the very next cycle, there it went down again. It won't start. We went up there really quick because now it had people on it. We had loaded it with people, and we asked operations to hold it loaded with people. And we go up there, and there is this big person sitting in a restraint. And we're like, oh, that's why it's not working, because their restraint's not made. So we had 2 problems. One is that the person wasn't checking the little lights on the side because that light was out, and their bows were clearly open. Even the panel said that the bows were still open. Bows. B-O-W-S. Not sure how that's pronounced in a different language or what it might be, but that's what it is. So we said, okay, go ahead and open the restraints off. Open the restraints and let everybody out. Okay. And we watched this big person get up and walk out. And we're like, okay, we know what's going on now. We know why this is happening. And then we told the operator there, we said, well, there's 2 things. One is that person's too big to ride. And they're like, oh, is that? It's like, yeah, your restraints aren't watching closed. You need to be checking those lights on the side to make sure that they're closed before you hit the start button. Oh, I'm pretty new to this. We're like, okay, and they were, I think they were like they were running like a break or something, like the different operator was out that was normally supposed to be there. But then we also looked over and saw that exact same person get back in line again. Which there's no one in line, so they were just walking out the exit queue, back into the entrance queue, and coming back around. And we were like, all right, the second thing is that you have to tell that person that they're too big and can't ride, because they're not letting the restraints close all the way. That's the reason why your ride won't start. And they're like, oh, can you guys tell them? And we're just like, no, we can't, because maintenance is too gruff for these issues. We don't care. We will tell people flat out how it is, and that makes people cry. So we've learned for a long-standing history is you don't let maintenance talk with don't let maintenance talk with your park patrons, because a lot of times it doesn't end well. When you're talking to a bunch of mechanics, it's a whole different story out there. So that was an interesting one for that. As far as other things out there, you have a 3-year inspection. There's 2 of them for that ride. The first one is that all the restraints, the bars that come over and hold you, all of them have to be x-rayed. And they called out x-ray specifically. So every 3 years, all of them had to be x-rayed. So that was always a fun one, setting up an area, because we didn't take them off the ride, we left them on. So the NDT stands for non-destructive testing. The NDT company would come up and take films and stuff of all those restraints out there to make sure what they are looking for is that the bond between the polyurethane foam that the restraint's padded with and the steel bar was broken on some of them in other rides. That allowed moisture to seep down between the foam and the bar, and it basically corroded the bar down on that part where you couldn't see it at all. So from the outside, they looked great. On the inside, they were paper thin. So that was a service bulletin came out that all the parks had to start NDTing the restraints via X-ray every couple of years to do that. Also, those ratchet mechanisms in the back, they had to be dismantled and inspected for a wear criteria. The interesting thing about that is that it could only be done by HUSS or a HUSS manufacturer's representative. So that was really tricky to do. We always had the representative come out and inspect our restraints. We took them out of the ride. We brought them down to the shop. He spent a couple days there checking everything over, making sure they were good. And we said that was the best way to execute that. So that was good for that. Occasionally, we had to pull the swing drive motors off to be rebuilt. They were big, they're DC, they were out in the elements, they had a lot of torque going through them. So occasionally those had to be rebuilt. So swing drive number 2 was easy. We set up a crane next to the ride. They swung over, reached down, grabbed number 2, picked it up and off and sat it down. No big deal. Number 1 was much harder. It was directly underneath the gondola. You can't just lift that thing up where it sits and pull it off because you have the entire gondola sitting on top of it. Well, these rides were meant to be more along the lines of a traveling ride than the permanent ride. So what you had was, it's like what we had to do is we had to take the gondola and we had to remove the entrance catwalk, the entrance walkway. It all looks like aluminum sheet metal, basically, that the walkway is for the entire center of the gondola. We had to take one slice of the pie essentially out of it and remove it completely and make the gondola now look like a big Pac-Man symbol. And we had to rotate the Pac-Man around until the mouth of the Pac-Man was sitting right over swing drive number 1. That way we could reach down, pick the motor up, and then carefully jib the arm over until it was clear of the gondola, and then lift it up and out of the way of the structure. Kind of like a Tetris move to get that drive out of there, but that was the more difficult one to pull out. Now, along those lines, we had those motors rebuilt a ton of times, but the actual arm, that swing drive arm that would hold the drive and the gearbox, we actually had to take those out like 4 or 5 different times because they would crack apart. They would crack and break, which was no fun. We go out there where that tire was skipping off the gondola, off the bottom of the keel, I should say. The tire was just bouncing, and we're like, why is that bouncing so much? And we shut the ride down and we'll lock it out and go down underneath the ride and look at it, and that arm is just completely split in half. Not like parts laying on the ground, but it left the top layer intact, and then the crack just opened up like a big V, and all the tension went away from the airbags and everything, and it was just like, oh, that's gonna suck. We had to take that out and send it to a place. They had to use special equipment to basically pull it back together, then grind it out, bevel it, re-weld it. They had to add stiffener plates and extra gussets to it, so that didn't happen again. We had that happen on both arms at 2 separate times. You could see I have a video where there is one of these arms sitting right in front of the camera, and if you stop and look at the video, there is the original gussets underneath it that I was one of the people like, okay, like these have to go on. So there's those original gussets sitting there. And then there's also a fish plate on top of that little edge as well. That is the part where like they must have had some extra trouble, or maybe further years of use also said add this little fish plate to that area. Very high stress point in those particular arms. That was no fun. Now, speaking of cracking things apart, we had a cracking good time with the keel. That was fun as well. Same trouble call, same type of trouble call. We get up there, and as the gondola passes by, it's making a thump-thump sound. Operations was like, why is it making a thump-thump sound? That's a good question. I don't know. Why is it making a thump-thump sound? Well, let's look at it. And then we start watching it as the gondola runs over it backwards, and it's like, yep, every time the drive tires go over it, it makes a thump-thump sound. The 2 drive tires, thump-thump. I wonder why. So we shut the ride off, go down underneath to look at it more carefully, and the technician at the time calls it. I was pretty new there at the time, but the technician calls up and says, "Hey, found the problem. What's the problem?" It says, "There's a giant hole in the keel of the ride." It's like, what? It's like, yep. So on the outside of the keel, they had used like 3mm, 4mm thick plate. Kind of thin, but I mean, it's plate. It's heavy duty. And over time, that had fatigued and just spider cracked all over the inside, but on the inside, the part where we couldn't really see. So one day it was going along, and then suddenly all those spider cracks are now bigger cracks, and in no time flat, those cracks suddenly opened, let the material flex back up on the inside, and the thump was actually the drive tire going up into the keel and then coming back out. Like, it was like, oh, that sucks. That really did suck. We had to take off the gondola. We had to drop the keel down and then remove it, which on permanent rides aren't fun. On the traveling ones, they just, it's a normal teardown for them. They just do normal stuff and it's all there. For permanent rides, it's not things you normally tear down. So I was like, okay. So we took the gondola out, or we took the keel out, I'm sorry, and we shipped it off. And they put like 1/4 inch, because we're in the US now, right? We put like 1/4 inch plate back over the top of it, did it again, put it back on there. I don't know what the deal was between engineering and the repair or what happened, but it didn't work. So just like a year later, we started getting stress cracks again in that exact same area, exact same way. Like, it didn't even last a year, and it started cracking. We could see the cracks now. It's like, crap. So we shut it down, had to do the whole process over again. This time, we are like, we are not dealing with taking the gondola apart, and we're not dealing with all that. That was a complete disaster last time. So we talked with a specialist manufacturing company, and what they did is they actually came out on site and in place cut the entire face plate off of that keel again, and then they took 1/2 inch plate and welded it back on top of that, and they added more reinforcements and gussets on the inside. That we did not have a problem with after that. We took some 1/2 inch plate. That thing was pretty friggin' stout when we were done with it. But that was one of those really nasty repairs. It was just like, oh my gosh, I don't wish that upon anybody. That was nasty. One of the things that didn't help is that when we started, there was a supervisor who was really good at dealing with this stuff, and I was learning from him. And we were talking about this ride because we were like, you ever, if you sat there and just like laid underneath the ride, like, hey, looking at the stars in the skies, it's amazing. As the gondola would swing up, it didn't just swing up straight and then come back down. To the naked eye, it was like, yeah, it looks like it swings up straight, comes back down, no big deal. But if you got something else in your vision, like some trees off in the distance or something like that, as it came up, it actually did a figure 8. It waved around like that and then would come back down. And we were like, why is it waving side to side like that? Why is that? And so we were looking at stuff, and then we came across the original installation prints for the ride. We're like, okay, let's look at these. And it gives you all sorts of measurements. Of course, it's for the construction crew to lay it out. And then we said, well, what do they see? Oh, well, let's go up and look. And we started measuring stuff out. And then we looked down the drive tires, and how you can kind of see right on there. You're like, okay, those tires are pretty well in line with each other. Well, when we looked down ours, one was crooked, like this, and the other one was in line. Like, why is swing drive 1 crooked? So we looked back at the prints, and we're like, why is this crooked? Doesn't say it should be crooked. And then we did the math on it. We said, actually, funny enough, those are not supposed to be in line with each other. They're actually supposed to be staggered with each other. Basically, the surface of the drive tire was, let's say, 200 millimeters wide. So if you looked at the keel underneath there, there should have been a drive patch underneath there about 450 millimeters wide. That was 200 with a 50 millimeter space in between. That should be the drive surface underneath there. So one tire always ran on one side of the keel, one tire always ran on the other side of the keel. If one got oily, it didn't affect the other one, right? Basic stuff. So it's like, okay, but we went out there and the measurements were so close to each other. Again, they were only offset by like 150 millimeters. That's it. What we're guessing, because we don't know, is that when they installed the ride, they did everything correctly. They put it all in there. And then as they were setting that swing drive 1 in place, they realized that it wasn't pointing directly at swing drive number 2. And somebody in the field was like, uh-oh, they're not in line with each other. They're crooked. Well, they were supposed to be crooked. But they didn't understand that for some reason. Nobody looked at the math on it, and they're like, they're supposed to be offset with each other. So they just went, oh, crap, they don't, so what are we going to do? Well, we're going to take this one back here, and we're just going to go like that, and then we're going to go like, that one's good. It's good. It's good, boss. We're good. Mr. Jones, how much you pay for the new guy? It's $2, too much. No good operator, right? So they actually twisted one of the drives to make it in line with the other one, even though they were supposed to be parallel with each other, but offset. Parallel, offset. These were kind of offset, but they were no longer parallel. They turned them to where they were in line. Not very straight either. That was causing our figure 8 motion as the gondola swung up full height and came back down. Nothing we could do about that. That was a mistake literally set in concrete. We couldn't fix that one. Okay, I think that's about it for this video. Make sure you like and subscribe, do all that stuff downstairs. It does help me out, and I do appreciate it. If you want to add on to this, these are some old rides. I have plenty of people on this channel that I know have a ton of stories for these things. So if you want to add on to that, let me know. If you want to say your cool stories you have, or maybe some cringeworthy stories you have, throw them down in the comments. If you want to ask me more questions, maybe away from YouTube, I have an email. It's ryantheridermechanic@yahoo.com. And I typically answer back most emails on there, but it gets kind of hectic from time to time. And this ride doesn't really have them, but you should still stay off the air gates. Bye.